Welcome to Học Tiếng Anh với Joseph, where we build vocabulary and practice pronunciation through reading. Continuing with The Cat in the Box, A History of Science in 100 Experiments. Today we will read story number 71. Hôm nay chúng ta sẽ đọc câu chuyện số 71, Splitting the Atom. The important thing about so-called atom splitting experiments is that they actually split the nucleus, the tiny central kernel of the atom first identified by Ernest Rutherford. It is the number of positively charged protons in the nucleus that determines the nature of the atom, what element it belongs to. Hydrogen has 1 proton per atom, helium 2, and so on. The electric charge of these protons is balanced by the negative electric charge of an equal number of electrons in a cloud in the outer part of the atom, 1 for hydrogen, 2 for helium, and so on. The arrangement of electrons in the cloud determines the chemical properties of an element. The nucleus also contains neutral particles called neutrons, which do not affect the chemistry. Atoms with different numbers of neutrons but the same number of protons are called isotopes of a particular element. For example, some atoms of helium have 2 protons and 1 neutron and are known as helium-3. Others have 2 protons and 2 neutrons and are known as helium-4. The particles in the nucleus are held together by an interaction known as the strong nuclear force, which has only a very short range but affects both neutrons and protons and is powerful enough at short range to overcome the natural tendency of the positively charged protons to repel one another. But the bigger a nucleus is, the more protons it contains, the harder it is for the strong force to overcome the electric repulsion, which makes it possible for heavy nuclei to split or fission into 2 or more lighter pieces. This is the process that people usually think of today when talking about splitting the atom, the kind of fission involved in a nuclear bomb or nuclear power station. But it is also possible to force nuclei to split by bombarding them with high-energy particles from outside. This is what John Cockcroft and Ernest Walton did in the first atom-splitting experiments at the Cavendish Laboratory in Cambridge on April 14, 1932. Rutherford was the director of the laboratory at the time and had suggested that Cockcroft and Walton should combine their efforts on the project. The realization that such a project might be feasible was inspired by a visit to Cambridge by the Russian theorist George Gamow in 1929. Gamow had calculated that under the right circumstances, a relatively low-energy particle could penetrate an atomic nucleus and trigger interactions there. Cockcroft worked out that a proton accelerator running at a few 100,000 volts might do the job, and it seemed that such an accelerator might be built with the limited resources available at the Cavendish. As Cockcroft later said in the speech at a Nobel banquet, new ideas combined with new technology to make many great discoveries possible at the time. Cockcroft and Walton brought separate skills to the task. Cockcroft was a theorist who worked out what was possible, while Walton was a superb experimenter, a hands-on man who built an apparatus that accelerated protons or hydrogen nuclei down a tube across an electric potential of just over 700 kilovolts. This was an early example of a so-called linear accelerator. The proton beam was directed at a target made of lithium, a soft metal in which each nucleus has 3 protons and either 3 or 4 neutrons. The bombardment produced traces of helium, atoms with only 2 protons in each nucleus. The helium was in the form of fast-moving alpha particles, essentially helium nuclei, which Walton detected by watching the flashes made by these particles when they hit a paper screen coated with zinc sulfide. To do this, he sat in a lead-lined box to protect him from radiation, peering through a microscope focused on the screen. In order to work out how much lead was needed, a zinc sulfide screen was hung on the wall inside. If it glowed, another layer of lead was added. Lead lachi. Walton wrote, "In the microscope, there was a wonderful sight, lots of scintillations, looking just like stars flashing out momentarily on a clear dark night." Rutherford himself had investigated and named alpha radiation at the end of the 19th century. When he was brought in to see the experiment, he said, "Those look mighty like alpha particles to me." A crucial clue was that the flashes occurred in pairs, showing that 2 alpha particles had been emitted simultaneously from the same source. This became known as splitting the atom, but it was actually a 2-stage process in which an incoming proton briefly combines with a lithium nucleus to make a nucleus of beryllium containing 4 protons, which in turn split in 2 helium nuclei. The team shared the Nobel Prize in 1951 for their pioneer work on the transmutation of atomic nuclei by artificially accelerated atomic particles. Let's head to the vocabulary section. Atom splitting, atom splitting. Kernel, nucleus. Arrangement, isotopes, isotope. Tendency, tendency. Repulsion, repel, repulsion. Fission, fission. Bombard, bombarding. Penetrate, trigger. Potential, flashes, scintillations. Simultaneous, simultaneously. Transmutation. Thank you so much for your time. And as usual, I will see you in the next story. Bye for now.